go to y equals clear. I did this problem again with the other class a minute before you came in. So x squared, here's your x right here, x squared plus 6x plus 8. Let's click on zoom and use the standard viewing window, use zoom 6. This is all of what I expected. It crosses at 0, 8, it crosses at -4, 0, it crosses at -2, 0. It will not show the axis of symmetry, however. Let's say I have another function that I could not determine the x-intercepts, or, bless you, or I want to determine them with a graphing calculator. Here's how I do it. Second and calc, and we will choose 0, 0. I want to find the 0 of this function. Then the graphing calculator will ask us to give it some boundaries, where to look for the x-intercept. To look here, or look here, or look here. Well, I already know that the answer is this, right? I already have the answer, but let's say I don't. I don't know exactly if it crosses at -4. I want the calculator to give me the answer. So I will give it a left bound of -5 and a right bound of -3. So -5, enter, and you see the graphing calculator will show me that that's where I told it to start looking for the 0. And then I'm going to give it a -3, and it will show me, look, this is what you picked. Are you sure you want me to determine the x-intercept between these two? Yes, I am sure, because I see it's right between them. I don't want to guess, and I just press enter again. And the calculator is giving me -4, 0. Now, if I want to determine the other one, I will repeat with second and calc, and I know I'm looking for a 0 of this function, so I want 2, item 2. But this time I want to look for this one. So between -3 and -1. So I'm going to say -3 is my left bound, and -1 is my right bound. I did something, of course. Don't I always do something? Okay, so I want the 0. Now I want the negative, what was it, -3 and -1, and I don't want to guess. Yes, I see the limits are exactly what I wanted. Yes, give me that -2, 0. Now I also want the calculator to calculate my minimum, the minimum of this function. So it's right in here. So did I start that? Yes, I did. Okay, so I wanted to calculate the minimum. So now I go back to second and calc, and I'm going to use 3, which is the minimum. Again, the calculator is going to ask me, okay, where do you want me to look for that minimum? And I will say somewhere between -4 and -2. So I'll give it -4, enter, -2, enter. And the calculator is telling me, okay, again, are you sure this is what you want? Yes, I'm sure this is what I want. I don't want to guess. I'll press enter, and it will give me -3. This is the tolerance or the error of the calculator. So you can disregard that. We know the answer is -3, not 0.000002. So it gives us the minimum. It will not give us the y-intercept. So don't rely on the calculator. Please do everything from your knowledge. It will be always better. Any questions on this, on the calculator? Okay, let's go back. So let's choose another function, and then I like to look at some word problems here, which are very important. Okay. Let's choose, let's say, 45 on page 703. On page 703. So f of x equals -5x squared plus 5x. Not all functions are as friendly as the first one was. Okay, So I look at this function. I'm asked to graph it. That's all I'm asked to do. Graph this function. The first step is the shape. I have to establish whether it has a maximum or a minimum. Does it have a max or a minimum? Always remember the quadratic function, always, like with everything else, put it in descending order. So you're certain that you are identifying A, B, and C correctly. Okay, what is the shape? Maximum indeed. A is -5, which is clearly a maximum. Number 2, I need to determine the vertex. How do I find the x coordinate of the vertex? Yes, from the quadratic formula, the first piece, the bottom piece, and no square root. That's how you remember it. Negative. Can anyone give us B? 5. Can anyone give us 2 times A? But since the leading coefficient is negative, 2 times -5. 2A. -10. Yes. So simplify, this is 1/2. As you see, this is not a friendly number to work with. Good. How do I find the y coordinate? Once I have x, yes, I have to plug it in. So f of 1/2. -5 times 1/2 squared plus 5 times 1/2. I would have liked to factor something, but that's okay. So -5 times 1/4 plus 5/2, or -5/4 plus 5/2. The least common denominator. Four. Multiply this by 2. A -5 plus 10. So it's 5/4. So the y coordinate is 5/4. Any questions? Yes, Becky? Yes, plus 5x. Did I copy something else? Oh, sorry. My apologies. Okay, so that's the vertex. And number 3, x-intercepts. But do they exist? Yes, because I know the parabola looks like this, and its maximum value is positive. If its maximum value were negative, it would have not touched the x-axis. But its maximum value is positive, so it has to cross the x-axis to get to a positive value. Very good. Good. So then how do I find the x-intercepts for this function and for any function? I said y equal to 0, right? For finding the x-intercepts, I said y equal to 0. So -5x squared plus 5x equals 0. Good. Yes, I will divide both sides by -5 because I want to simplify. So then I get x squared minus x equals 0. And I cannot divide by x. That is not allowed. Yes. So then I have x times x minus 1. Remember the greatest common factor? When one of the 2 or the 3 terms is missing, it's always easy or easier. So I factor out x. So then we have 2 solutions. And what are those solutions? Which solutions am I talking about? 0 and 1. So then the ordered pairs are 1, 0, 0, 0. So there is no point in finding the x-intercept. It's already there. When x is 0, y is 0. I'm sorry, I meant y, of course. The y-intercept, when x is 0, y is 0. And now I need 5 and 6, just words. What is the axis of symmetry of this parabola? The vertical line, x equals 1/2, axis of symmetry. It's the vertical line passing through the vertex. Does this function have a max or a min? Max. What is the max value? Max value is 5/4. Can anyone picture the graph and tell us the range without even graphing it? Right. So the range is -infinity to 5/4 to the y value that is maximum. Very good. We need to graph it. What do I graph first? Yes. I have to plot the vertex first. So 1/2, I'm going to say this is 1. Okay, I'm going to say 1/2, 1 5/4 right here. So this is 1 and this is 1. This is 1.5. Then the axis of symmetry, just to help me keep the graph in shape, symmetric. Then I plot 0, 0 and 1, 0. And that's it. Try to make it as symmetric as possible. Is my graph symmetric? Of course not. It's not perfect, but at least I don't want to see something like this. Okay, I will not look at it this with a magnifying glass, but please make sure that. So this is f of x, -5x squared plus 5x. I'd like to look at a couple of word problems, and then we'll come back to the other form. On page 704. And I forgot last time, I was supposed to give you 15 minutes back, and I forgot. So can we do it today? Is that okay? No, no, no. No, just 15, and I'll give you the rest. No, just 15, I promise. But I still have 3 more. I gave you ones, but I forgot the second one. Sorry about that. Okay, 58. No, just 15 minutes. I know it's a lot, over 2 hours of math. The Utah Ski Club sells calendars to raise money. 58 on page 704. So they sell calendars to raise money. The profit P in cents from selling X calendars is given by the equation. So P of X equals 360X minus X squared. P is in cents. X number of calendars. First question, how many calendars must be sold to maximize profit? Second question, find the maximum profit. My first question to you is, what type of function is this? Quadratic. Then my next question is it this in descending order? No. So I have to rearrange it. So this is -x squared plus 360x. My next question is, does it have a max or a min? Yes, because the leading coefficient is I'm asked to determine the number of calendars that will create a maximum. What do I have to do? Exactly. Find the vertex. Good. How do I find the x-coordinate of the vertex? Something that we know from the quadratic formula. -b over 2a. Negative. B is over 2 times A. Perfect. The answer for how many calendars will produce a maximum profit? Now the question is, what will you tell the Utah Ski Club? If you sell 180, not 181, not 185, not 170, but precisely 180, you will get a maximum profit. And they will ask you, what's the maximum profit? And you will say, that's it, P of 180. Negative 180 squared plus 360 times 180. Grab your calculator and let's calculate. So negative 180 squared plus 360 times 180. I got 32,400 cents, or $324. Any questions? And that is the maximum, 32,400. 63. Any questions? Did I do something wrong? Okay, you're not convinced? Let's see. Did I do something wrong? So negative 180 squared plus 180 times 360. Is it okay? Yes?
Yeah.
Okay. Careful with the, you cannot do parentheses around negative 180. Maybe that was the problem. Okay, very good. 63. Same page. The length and the width of a rectangle must have a sum of 40. Yes. Ah, thank you. The length and width of a rectangle must have a sum of 40. What should I write?
X plus 1.
Perfect. Find the dimensions of the rectangle that will have the maximum area. Find X and Y for max area. Find the length and the width for max area. Okay. In order to find a maximum, I have to have something to find the maximum for. So what am I going to determine or create or find and then find its maximum? What is the key word here? Of what? Max area, indeed, so the area. So now I'm going to create a function, f of x, that represents the area. So let's start by writing what will the function be. What is the area? How do I express the area of this rectangle? That's my first step. Good. But I have two variables. So I have to get rid of one of them because that will not be a function of x. I cannot. This will be incorrect. I don't want to get rid of x. I would like to get rid of y. I cannot write this. Very good. Okay. Okay, got it. You're right. In this particular case, the width was denoted by y, but it had nothing to do with y. It had nothing to do with this y. But you're correct. It's some contradiction here, right? Because I'm using y for this and also y for this. So let's use a and b, and then I'll change them. So the function is a times b. This is the area, correct? So far, so good? I want to get rid of one of the variables because, as you said perfectly, Matt, this is y, one variable. This is the second variable, which is a, and this is the third variable, which is b. I don't know how to handle 3 variables in a function. We don't know that. Not till Calc 3. So we can use this, 3 variables. So, but I have to use what I'm given. I'm given a relationship between x and y. So I could, or a and b, sorry. So I could eliminate one of the variables using this relationship. Let's say we want to eliminate b. So what should I do here? I want to solve this equation for b, which is 40 minus a. I'm going to replace b in the area by 40 minus a. So then now I have a times 40 minus a is a function of a. Since we changed from x to a, let's keep it a. Keep it a. It doesn't matter. It's not important. So then f of a will be negative a squared plus 40a. I distributed and also arranged it in descending order. I would like to start from the beginning by discussing what we did step by step. We were told that there is a rectangle, length and width, and we were told that the sum of these two equals 40. We are asked to find what the length and the width, how wide and how long should the rectangle be, in order to have a maximum possible area. I can't determine the maximum of something I don't have. So I have to find the area. I have to create a function whose maximum I will find. So I start with the keyword area. I write a times b. So the area is a times b. But now I have 3 variables. I have the function, which is the y variable, and I have 2 more variables in here. So somehow I have to get rid of one of these 2. Now let's say I choose to solve the equation for b, subtracting a. So then b will be replaced by 40 minus a. So now the area, which is a function of a, has a and has b replaced by 40 minus a. I distributed a to negative a to get this, and a to 40 to get this. Now I'm happy. Why? I have a function that I know how to find the maximum for. So then, tell me what to do next. I have the function. I want to find its maximum. What type of function is it? Does it have a maximum, by the way? Because I may want to find its maximum, but if it doesn't have a maximum, I can't find the maximum. Yes, it does, because the leading coefficient is negative 1. So then the vertex is what will give us the maximum. I have to find negative b over 2a. Negative. What is b? What is 2 times a? So the answer is 20. So what was a? A was the length. Do we have a measurement unit? No, it doesn't say. Okay, so the length is 20. Can anyone tell us how much is the width? If their sum is 40 and the length is 20, how much is b? Very good. So the width is 20. Now if I want to, it doesn't say, but if I want to determine, maybe it does. It doesn't, bless you. What if I want to find the maximum area? What will it be? Yes, 20 squared. 20 times 20, which is 400. So that'll be 400. I have to write one sentence as a conclusion here. The maximum area of a rectangle with length plus width equal 20 is 400. The dimensions are length 20, width 20. So in conclusion, the rectangle with the maximum area is actually a square. So the maximum area of a rectangle with length plus width equals 20. I'm sorry. Equals 40 is 400. That was the condition given to us. The dimensions are length 20, width 20. Okay, let's look at one more word problem and then we'll go back and graph some more functions. 60. Any questions? Find two numbers. 61, because 60 is very similar to what we just did. Find two numbers whose difference is 10. They differ by 10, and whose product is as small as possible. Product, smallest. Find two numbers whose difference is 10 and whose product is as small as possible. What are the keywords here? Yes, absolutely. That's one keyword, the minimum. Perfect. Then differ and product. The product will give me the function. Okay. So I have to state something that tells me that two numbers differ by 10. And they have to be unknown. I cannot say 20 and 10. They differ by 10. So I have to use variables and create an equation with two variables that differ by 10. Okay, a minus b equals 10. Perfect. Now I need to create the product of these two numbers. It's very similar to what we just did. The product of these two numbers is a times b. Perfect. I have to get rid of one of them. It doesn't matter which one. But I can, this is not a function that is quadratic yet. So from here, tell me which one would you like to solve for? Perfect. So a equals? Yes, or b plus 10. Now I can say that this product is a function of b and of b alone. And tell me what to write.
B times B.
And I distribute finally. Now I have the function. I will ask myself, does it have a minimum or a maximum? Because if it doesn't have a minimum, then I'm not on the right track. Does it have a minimum?
Yes.
Good. How do I find the minimum? The vertex. How do I find the x-coordinate of the vertex? How much is b? Not to be confused with the b in the problem. It's the coefficient of the middle term. 10 over 2 times a. So the answer is? Good. So b is negative 5. Now let's come back here. If b is negative 5, how much is the other number? 5. What will be their product? If a is 5 and b is negative 5, the product is this. What is the minimum product? Negative 25. I have to conclude with one sentence, and I would like you to help me this time to write it. The minimum product of two numbers that what? Very good. Is excellent. The numbers are and 5 respectively. Very good. I like to go back to graphing. Let me go back to graphing. Any questions? Doing another word problem. Well, on Tuesday, I'm going to review the entire thing from scratch. Every type of problem. But do we need another word problem now, or can I go back to graphing? Graphing? Okay. So I would like to go back to this, which we have not discussed yet. But I like to build it step by step. I don't want to just say, hey, this is this, this is that. Okay. Let's think about this function.
So it's minus h, right?
Yes, h and k. I'm going to start with this function. It's the simplest possible quadratic function. You can't find a simpler function, quadratic function, than this one. Does it have a minimum or does it have a maximum? Minimum. And where is the vertex? Right. Where are the x and y intercepts? Right. So this is x squared. Now I would like to graph the following function. I'm going to call it f1 because it's not the same with f. X minus 1 everything squared. Where does this graph go? Where do you think it goes? So which number minus 1 will give us the x-intercept? That's where the graph is going. 0 minus 1 will not give us y0. Which number will give us the y0? 1. So where does this graph move in order to graph this? To the left or to the right? To the right. Very good. To the right. So this graph will be here. Same graph, identical graph, but it will move to the right. What about f2? Let's say x plus 4, everything squared. Where will this graph go? Not in comparison to the green one, to this f1, but to the original function. So when I change x into x plus 4, where will I shift this graph horizontally to get this graph? To the left, how many? 4. 4. Very good. So here it is. This is the x plus 4 squared. Okay, stay with me. Now I want to add something else. Let's say I have f3, which is x squared plus 1. Don't say anything just yet. Give me 1 second. And I want x squared minus 3. I'm not changing x now. As you see, x squared did not change. So this cannot be a transformation that will move the graph x left or right. So x squared stays the same. But now this graph is moved where? 1 unit. Plus 1. So not to be confused with this. This one moves the graph to the right. This one moves because I still have to be on the x-axis. But this one, it moves it up 1, and this one moves it down 3. Okay. So if I graph again x squared, and I want to graph x squared plus 1, this will be the graph of x squared plus 1. And this is x squared. If I want to graph x squared minus 3, this will be the graph of x squared minus 3. I'm going to combine those two because I want you to tell me what this is. So now I'm going to ask this. Let's say f of x, f5, is x minus 4 squared plus 3. Now, if I graph x squared, I need to graph this portion first. Where does this graph move? Where does x squared move in order to get this? Right 4. So this is x minus 4, sorry, squared. I'm going to erase that. And now what will I do with this graph? Move it up 3. Very good. So up 3 of this graph, 1, 2, 3, right here. Can anyone now, without any calculations, give us the vertex of the red graph? Very good. Now, without any more explanation, I will explain if we need to. Can anyone give us the vertex of this graph? Exactly. That's the only difference between the two forms. One, from before, we had to sweat to find the vertex. For this one, I don't. Because of all these shifts, left, right, up, down, I come up with h, k being the vertex. So let's choose a problem on page 696 and graph it. And graph it using this concept. And that's it. That's the last thing I need to show you. Okay, on page 696, do I get to choose or you want to choose? I'm going to choose 16. We are given a function, x plus 3, everything squared, plus 1. I have to go through all the steps we're asked to graph. Can you envision the graph without even graphing it? Remember, this is x squared. Where does x plus 3 go? And then, what's the vertex? Careful.
-3.
Right, you told me to move it to the left, right? Good. So the vertex is -3, 1. Remember, this has to be minus. Meaning, I can rewrite the function as x minus negative 3 plus 1. That's how I get the negative 3. Because it shifts to the left 3 and up 1. Will this function, see, now once you understand what's happening here, I can even ask you, will this function have x-intercepts? 696. Sorry about that.
No.
No, because it shifted to the left. Yes, it goes up and it goes, yes, it has a minimum, right? So it does not have x-intercepts. Can anyone already give us the range of this function? Because I know it's in your head already. 1 to infinity. So I know that I have the vertex and I can only find the y-intercept. There are no x-intercepts. So let's go through step by step now. Yes, Mike?
I was going to say, in what case would you reflect it off of the axis?
If I have a negative leading coefficient. I'll do that in a minute. So I'll have to show you that for example, and I'll come back to it. So let's say f of x equals negative x plus 1 squared, let's say, minus or plus 4. So first I shift it to your left 1. Then I flip it. And then I move it up 4. What will be the vertex now? Negative 1 comma 4. What will be the range of this one? Okay, so we go through the same steps. In step 1, we find the shape. What is the shape of this? The leading coefficient is still the same in our outside, so the leading coefficient is 1 greater than 0, so we will have a minimum or a maximum. That's it. Now, with no effort, you can give me the vertex, which we already have. Negative 3, 1. Number 3, no x-intercepts. Number 4. Now, number 4 is slightly more difficult. I have to make x equals 0, so I have to find f of 0. It was easier before 0, 0, and the last number was the y-intercept, but here I have to calculate. So let's calculate together. 0 plus 3. 3 squared. 9 plus 1. 10. So 0, comma 10. 2 words here. Axis of symmetry. X equals? Good. And you already told me that the minimum is 1. So let's graph it. Negative 3 comma 1. Here's the point. Graph the axis of symmetry. And 0 comma 10. 2, 3, 4, 5, 6, 7, 8, 9, 10. You can say, is this enough? Yes. Can you find other points? Please do so if you feel like it. So here's how I determine another point. Knowing that it has to be symmetric, right? So I have here 3 units to the right. I'll go 3 units to the left and make an mirror image of that point. So I made a mirror image of the y-intercept. So I got that f of x equals x plus 3 squared plus 1. And yes, as you said, the range is indeed 1 to infinity. Any questions? Any questions? We have a few more minutes. Let's choose either a word problem or another graph. What would you like? Another word problem. Okay, very good. So let's choose. On page 704. the projected number of Wi-Fi enabled cell phones in the United States. 87 on page 704. Can be modeled by a quadratic function. Cell phone numbers of x, negative 0.4 x squared, plus 21x plus 35. C of x is the projected number of Wi-Fi enabled cell phones in millions. And x is the number of years after 2009. Number of years after 2009. So for 2009, how much is x?
Zero.
Very good, perfect, thank you.
What's example?
Number of cell phones, enabled, Wi-Fi enabled cell phones. Will this function have a maximum or a minimum? Yes, the function will have a maximum. Maximum since a equals negative 0.4. Perfect. Part B. According to this model, in what year will the number of Wi-Fi enabled cell phones in the United States be at its maximum or minimum? Where we already established is the maximum. So according to this model, in what year will C be maximum? What do I have to find?
The number of years.
Yes. What do I have to find in order to find the number of years? Oh, yes. Or if you want to say what, yes. How do I find the number of years?
The vertex.
Negative b over 2a. Very good. Negative. How much is b? 2 times a. 2 times negative 0.4 is negative 0.8. So in other words, 21 divided by 0.8. I got 26.25. So this is the year. Years after 2009. What will that be? In 2035. And the last question. What is the maximum or minimum? Of course, we established it's a maximum number of Wi-Fi enabled cell phones. Round to the nearest whole million. How do I find the number of cell phones Wi-Fi enabled in 2035?
You said X.
Say it again.
You plug in
I plug in 26.25 in the function. Very good. 26.25 equals negative 0.4 times 26.25 squared and plus 21 times 26.25 and plus 35. So I would put this in the graph calculator and see what I get. Negative 0.4 times 26.25 squared, and then plus 21 times 26.25 and plus 35. Okay, 311 million. Yes. Becky? Any questions?